Good day, everyone. This is O'Shane, and today we're going to be talking about the distance formula. Now, this is a very important topic in our bridge to geometry journey, and I'm going to introduce it in a little bit of a different way. But here's one thing I want to touch on prior knowledge. Okay, let us say I have this x squared is equal to 16. Okay, you might ask yourself, how do I find the value of x? Now, you might already know. If x squared is equal to 16, based on our last lesson on perfect squares, then I would ask myself, what number squared gives me 16? You know that to be 4. That's really what this is asking us. Now, how am I supposed to do this algebraically? Well, as I told you guys yesterday, let us do this. Let me write something. Let me use a number. The square root of 4 squared is equal to 4 because the opposite of a square root is a square and vice versa. They cancel each other out. Now, as you know, when we're solving equations, we actually focus on doing the opposite. So what would happen is if I had x squared is equal to 16, technically I could find the square root, follow me, of both sides. And this square root and this square root cancel, leaving with x being equal to the square root of 16, which would be x would be equal to 4. Now, there's another way. The next way is simply just understanding that, and I'm going to erase this, and I'm going to do that again, is simply just understanding that if I have x squared is equal to 16, because the opposite of a square is a square root, I can move the square over the equal sign and it will become a square root. So x will be equal to the square root of 16, which will in turn be equal to 4, right? Now, this is something that we should be able to do based on our lesson yesterday. Let's look at another one, right? So what about x squared is equal to 25? Well, if x squared is equal to 25, based on the last thing that we just did, we can say x would be equal to the square root of 25 because I'm simply moving the square over the equal sign and it's becoming a square root. Now, again, there are many different ways in which I would have gone about this, teaching it. The first way is to stay with the concept, which is to find the square root of both sides and the square root on this side, canceling that, leaving with the square root of 25. However, I really want to focus on just having us understand that carrying a square over the equal sign becomes a square root. Now, how is that connecting to what I'm trying to do today? Well, I'm going to introduce the distance formula by first talking about something that you guys already know about, a right triangle, right? And with a right triangle, you guys know that we have two legs and a hypotenuse. My O is hidden somewhere there. Now, two legs and a hypotenuse, right? This is every right triangle. Obviously, uh, in geometry or in algebra 1, the legs become like opposite and adjacent, but that's all determined or based on what we like to call theta, which is an angle, right? When we don't have angles or anything, we can just call them legs. Okay. Now, with a right triangle, we have the side with the right angle. The hypotenuse is always going to be the side that's opposite the right angle all the time, right? Just remember that. Now, here's a quick little example. I want to focus on that here. Don't want to spend too much time on it. Let us say that I would like to find, or instead of saying leg, leg, and hypotenuse, let us call this A, B, and C. And if I said to you, I want to find the value of C, how do I do that? Well, you guys would have known this. That's Pythagorean theorem, and the Pythagorean theorem says a squared plus b squared is equal to c squared. That's how we actually find the hypotenuse. Now, in this case, the hypotenuse being c, based on what I just showed you guys, could we then say that, I'm going to use this here, the square root, right, of a squared plus b squared, and this, I think I made this too long, is equal to c, because I'm carrying this squared over the equal sign, right, and turning it into a square root. Now, let's look at an actual example. So, let's use the simplest right triangle ever, right? The 3, the 4, and the, well, let's find out. So, if I wanted to find the value of c here, a would be 3 squared plus b would be 4 squared, and we're saying that's equal to c. So this will become the square root of 3 squared is 9 plus 4 squared is 16. That's equal to c. This will be equal to the square root of 25. That's equal to c. And the square root of 25 is equal to 5. And so c in this case is equal to 5. Now, here's why this is important. When I'm finding the length of a side of a triangle, I'm also finding the distance, right? So in essence, this is a variation of the distance formula, right? The Pythagorean theorem is a variation of the distance formula. What is the distance formula, you may ask? Well, take a look at it. So here's the distance formula. Now, the distance formula, to me, how I would say it is that the distance formula is simply the Pythagorean theorem on the coordinate axis. Instead of saying this is C, it's D for distance, right? Take a look at what I do here. So I said I have a line segment A, B, right? Line segment AB. And given a line segment AB on the coordinate axis, Y and X, this line segment will have 2 points, and each point will have an X coordinate and a Y coordinate, right? This is what we're saying, that the distance D is equal to the square root of x2 minus x1, which is x2 minus x1, right? Which is what? That is your x-axis here. The difference between these 2 points is your, let's go with the right triangle here, your a squared plus y2 minus y1. Do you see what's happening here, guys? Is your b squared. Now, I just wanted us to notice that. However, moving forward, I want us to also focus on the fact that the distance formula is really d is equal to the square root of x2 minus x1 squared plus y2 minus y1 squared. Or it's also equal to x1 minus x2 squared and y1 minus y2 squared. And we're adding them. And just remember, it's coming from this. C is equal to the square root of a squared plus b squared from the Pythagorean theorem. The biggest and most important part of this geometric journey for you with this topic is understanding that the distance formula is simply the Pythagorean theorem on the coordinate plane or the coordinate axis. Okay? Now, what is the difference between the two formulas? If you notice that both formulas are the same thing, it's just that the first formula has x2 minus x1, and the second formula has x1 minus x2. Now, the reason why both of these formulas will work is because when we take the difference between x2 and x1, or x1 and x2, we're squaring it. And the fact that we're squaring it means that our answer will always be positive. I think I did a little explanation here. So just remember this. The square of a negative is always positive. What does that mean? Negative 5 squared is equal to 25 because negative 5 squared is equal to negative 5 multiplied by negative 5, which is going to be equal to positive 25 because a negative multiplied by a negative is a positive. This is just something to remember. And remembering this, hear me out, remembering this is what's going to help you to understand that if I do x2 minus x1 and square it, I'm going to get the same answer as if I do x1 minus x2 and square it, right? I'm going to do a few examples, and so you'll get to really see what I'm talking about. Um, yeah, so let's move on to that section right now. Thank you. Okay, awesome. So here we have some examples, right? I'm excited. So let us look at the first question, right? Number one here. And it says find the distance between each pair of points. So best practice, always label your points first. X1, Y1, X2, Y2, right? The next part of what I would say is best practice is to write your formula. Distance, D, is equal to the square root, right, of x2 minus x1 squared plus y2 minus y1 squared. Now, we're just going to put those in, and we're going to put them in meticulously here. Follow what I'm doing. X2, which is negative 2, minus x1, which is negative 1 squared, plus y2, which is 1, minus y1, which is negative 3 squared. I should have another parentheses here. Okay, so distance is going to be equal to, now taking my time, negative 2 plus 1 squared plus 1 plus 3 squared. Okay, these two here, these two negatives become a positive, these two negatives become a positive, right? A negative beside a negative becomes a positive. And so distance will be equal to the square root of negative 1 squared plus 4 squared, which will be equal to negative 1 squared, which is just 1, plus 16, which will be equal to the square root of 17. And we're going to leave it like that, right? Unless the instruction asks us to round, then we simply leave it like that, okay? Obviously, based on our previous day's topic about simplifying simple radicals, if the radical can be simplified, then we're going to do that. Okay, now this is distance formula. That's the first example. Let's look at another one. Okay, so let's label our points. X1, Y1, X2, Y2, right? Distance is equal to the square root of X2. Oh, let's do it the other way. X1 minus X2 squared plus Y1 minus Y2 squared. Notice, if I go x1 minus x2, I'm also going to go y1 minus y2. Or if I go x2 minus x1, I'm going to go y2 minus y1. We just need to maintain consistency, right? It's called procedural fluency. Either way is going to get us the right answer, but I think it is important to maintain that mathematical fluency here. Okay, so distance will be equal to, let's go with 6 minus negative 6 squared, right? X1 minus x2. Then we're going to go with 2 minus negative 6 squared again. All right. Now, if I were supposed to do it the other way around, right? Just want you to look at this. If I were supposed to do x2 minus x1 squared, what would that look like? Well, it would be, I don't need the square root. I just want to show you guys something here. So it would be negative 6 minus 6 squared. So let's see what's happening. This will become the square root of 6 plus 6 squared plus 2 plus 6 squared. This will become negative, um, hold on a second here. There you go. Negative 12 squared. So what you notice is happening? Well, this would be 12 squared plus 8 squared. And this would be negative 12 squared, which is still a positive 144. And in this case, this one is still going to be a positive 144 plus 64. So in both cases, I end up with a positive 144. And that's because the square of a negative is always positive. All right. Now, 144 plus 68, that's 140 and 60, that's 200. And 4 plus 4 is 8. So we end up with 208. Now, this is what I want us to be able to do. I want us to be able to simplify this radical based on what we touched on yesterday. So we're going to divide 208 by our perfect squares. Okay? So 208, obviously, we know that if we divide it by 4, it's going to work. So 208 divided by 4, what works? That gives us 52. But let's keep going. 208 divided by 9 doesn't work. 208 divided by, what's the next one? 16. That also works. So 208 divided by 16 is equal to 13, right? So the one with the 4, there's a bigger one, which is 16 and 13. So, and I know if I get 13, it's a prime number. This is probably going to be the radical that I'm going to use. So this will be the square root of 16, the square root of 13, which will give me 4 root 13. This is my answer. Okay. So I hope you see how different things are coming together. I hope you understand that maintaining consistency with the formula is important, right? With your x1 minus x2, y1 minus y2, or x2 minus x1, you're gonna get the same positive answer, right? Let's look at another one. Okay. So right here, gonna do x1, y1, x2, y2, right? And distance is equal to square root of x2 minus x1 squared plus y2 minus y1 squared. Awesome. So distance is equal to the square root of 8 minus negative 4 squared plus 8 minus 2 squared. And so distance is equal to the square root of, this is 8 plus 4, which is 12 squared, plus 8 minus 2, which is 6 squared, right? And so what happens is that distance will become the square root of 144 plus 36. And this will give us the distance being equal to the square root of 180. Okay, 144 and 6 is 150 plus 30 is 80. Now, again, this is a radical that I need to simplify. Let's divide 180 by perfect squares. 180 divided by 4, that works. 45, you need a bigger one, okay? 180 divided by 9, I'm sure you see that. Let's see. That also works. 180 divided by 9, that works. But remember what I said yesterday, if my remainder is 20, it means I gotta keep going. 180 divided by 16 doesn't work. 180 divided by 25, obviously, that's not going to work. 180 divided by 36 works. So 180 divided by 36 is equal to 5. So I know that I'm going to use that, which means that the distance is going to be equal to the square root of 36 square root of 5, which will give me 6 root 5. Okay, hope we are understanding that. Similarly, I have here finding the distance, but in this case, it is on the coordinate plane itself. No, here's the trick for this one, right? Technically, you could, by understanding that you're dealing with the Pythagorean theorem, technically, if you did this, would it give us the same answer? Let's see. With this right triangle, right? C is equal to the square root of a squared plus b squared. Now, do you notice that the distance, whether it's positive or negative, doesn't matter. It's going to get us the same thing because I'm simply counting. So whether I count in this direction or whether I count in that direction, it's going to be the same distance, right? And when you touch on some physics and learn about distance and displacement, you understand exactly what's happening. So this is 1, 2, 3, 4, 5, 6. All right, so let's call that 6 squared plus 1, 2, 3, 4. Let's call that 4 squared. So this will be equal to the square root of 36 plus 16, right? And so what happens here is that we get the square root of 52, and let's divide 52 by our perfect squares. 52 divided by 4 gives us 13. Remember, if I get 13, then 13 is a prime number. So my answer is the 4 and 13. So this will become the square root of 4, square root of 13, which will be 2 root 13, which is my answer. I'm doing this because I'm showing you the connection between the Pythagorean theorem and the distance formula. So let's actually do this question by looking at the coordinates. So what is this coordinate? Well, that coordinate is x is equal to 4, y is equal to 0. And this coordinate is x is equal to negative 2, y is equal to 4. All right? And so x1, y1, x2, y2. And so distance will be equal to the square root of x2 minus x1 squared plus y2 minus y1 squared, which is going to give us negative 2 minus 4 squared plus 4 minus 0 squared. I hope you guys start to see it. So this will become negative 6 squared plus 4 squared, which will give us a square root of 30. Come on. 36 plus 16, which will give us a square root of 52. You get it? Now, what I want you to focus on is that you could have started to see that we would have ended up with 36 and 16 from we got to this point here, right? Because we're really just dealing with the distance between the x's, that's the y's actually, and the distance between the x's, okay? Now, as we are looking at this, I just want you to, you know, um, remember that you need to simplify your radicals when you get that chance, unless you end up with like a radical, like the square root of 17, that you can't simplify any further. Now, I did have some questions here that will require um, getting your answer and using your calculator and rounding to the nearest tenth. Um, just a quick refresher on that here. So let's say you get an answer 9.372, right? Just reminding you of your place value. I can use the same ink here, right? This is your tenth, this is your hundredth, This is your 1/1000th, right? So this is your nearest tenth value, right? And so if I want to round this number to the nearest tenth, the number I'm looking to change, if possible, is this 3. What I do is I look to the right of it. This number to the right of it, I say, is it 5 or greater than 5? If it's greater than 5 or 5, then this number 3 changes to 4. So this number, 9.372, rounded to the nearest tenth, is 9.4. Similarly, if I should say 4.729, rounded to the nearest tenth, I'm looking here again, and the number beside it is a 2, which is less than 5 or not equal to 5. So this will stay as 4.7, right? Just a quick reminder with rounding. I know it's something that sometimes we forget, right? So this is the place value, 1/10, 1/100th, 1/1000th, right? Tenths, hundredths, thousandths. Yeah. Okay. Anyway, guys, uh, I'll send you guys your worksheet and, you know,